Welcome to the special edition of the Uptime Wind Energy Podcast. And there is some activity in the lightning world in the IEC 61400-24 specification. Back in Annex L, and Annex L is about monitoring of wind turbines for lightning information. And there's an amendment being proposed at the minute by the working group, with the IEC working group, that is looking to put some more details around lightning monitoring for wind turbines. And I have Joel Saxum here with me, our Chief Commercial Officer at WeatherGuard Lightning Tech. And we think it's important that everybody realize that this is happening at the moment, and to make sure operators and owners understand the implications of these changes that are being discussed at the IEC level and what it means in terms of your future operations, your costs, some added complexities if you decide to go down this pathway.
Yeah, absolutely. So I think we should start with just a little bit of a discussion around the IEC standard and what it means for the industry. IEC standards are things that are adhered to as basically a technical specification. So if it's how wind turbines are rated, by what speeds they can take, or how certain things are designed in foundations or the lightning protection systems, it's what the industry looks to for guidance. So what ends up happening is if you run into maybe a court case or something of this sort, this document becomes a partial, basically, expert witness. Did you, hey, party A is suing party B for whatever on their wind turbines, and then this document will almost always come into play in that, whether it's an insurance case or it's a legal battle of some sort. Hey, did you adhere to the IEC standard? So while it isn't technically a law or something that you have to follow as a regulation, it is pseudo that in the legal world, right? So that it pops up almost all the time. All turbines, when they get certified against the IEC standards to be able to connect to the grids in most countries. So it is a very, very important document and has real-world implications for everybody in the wind industry.
Yeah, and there's been really two additions to it. There was an early edition back in the 2000s, and in 2019 they updated it with a lot more information from the technical aspects, from watching lightning damage to wind turbines and providing some feedback and how to test better. So there has been some more recent updates to the document. The monitoring side, though, was pretty scarce. There was an Annex L in the 2019 version of the document, but it was pretty simplistic. Like, you can put systems on your turbines to detect when lightning has struck, from as simple as the magnetic cards, the magnetic stripe cards, to as more complex, where you have uh, current sensors or monitors on each of the blades on the down conductors, so you can measure the current amplitude and durations and things like that. So there's a wide gamut of that. And this latest update is being more specific about the measuring the current parameters. Like, what should be measured, what sort of ranges and what sort of frequency bandwidths these pieces of instrumentation should have, and getting the manufacturers of this equipment to provide some of these details, which all in general are fine. Uh, if you can imagine, Joel, if you're going out to look at a new car, you get a bunch of specs, and on the cars, you're like, oh, I don't know what I'm going to choose here. Like, this one has a great radio, but this one has better tires, right? It's sort of like that. If you're an operator and you see this new update in the IEC spec, and this amendment they're talking about, there's a lot of technical info there, but as an operator, I'm not sure it would make a lot of sense to you. If I said, Joel, this particular monitor has a better specific energy or a better frequency range than that lightning sensor, would that make any difference to you?
Not in the grand scheme of things, to be honest with you. So as you know, here at WeatherGuard, we're lightning experts. So when this Annex L came out for possible changes to the spec, we dove in head first, right? We wanted to understand exactly what's being proposed here and give our 2 cents on should it be proposed? Is this the right way that the industry should be going? Does this make sense? What this new Annex L is saying? Is that data needed to be collected? If it is collected, what are we going to do with it? How is it actually going to help the industry? And then you kind of dig into the wording of a lot of stuff in here when they have considerations and benefits for the OEM, considerations and benefits for owner operators, and considerations and benefits for the insurance companies. You can see where they're going with the idea, but in my opinion, it's a little bit misguided. I think that they're they're reaching for an answer because they just don't know, right? The people that are in control of this section of the IEC standard, it's almost like the lightning research is a little bit lacking, and they're just saying we need to start collecting more and more and more data so we can figure out something to do with it. But it doesn't go on as far as saying, once we have this data, this is what we're going to do and this is what we're going to solve for a problem. They're just saying you need to go and collect all this data.
Yeah, and I think that's where the misstep occurs in the document. It does lead you to believe that with all this data that could be collected, that now there's some actionable information that engineers can use to then redesign or create this new lightning protection system for the next generation of blades. But the information they're collecting doesn't do that, which is the tricky part here. It implies that it does, but it really doesn't. Because the number one issue for blades in terms of cost, Joel, is what?
Lightning damages. And on the other side of it, the majority of those are force majeure. So someone has to pay for them, no matter what. They're not covered under warranty. They're not covered under any kind of contract. They're just, it's an open checkbook for service companies or service contract holders to bill the asset owners.
Right. So if you're an operator and you're writing a lot of checks for blade punctures, which is the thing that costs you the most money and has the most downtime, the insurance industry has said that numerous times at this point, taking these measurements that the IEC standard is asking for will not stop that. It will not change that result. And let me walk through that just real quickly here. What the IEC spec and the monitoring systems do is they measure the current flow of a lightning strike. So there's different parts of that lightning current. We put different kinds of parameters around it just to keep it simple here, but it's all current flow. And you can measure that, and that's really good information. But there has been no correlation between the type of current going through a blade and lightning damage. Those two do not sync up because you're looking at the wrong phase of the lightning event. And there's really two phases to it. And just like in the IEC spec, there's two parts to testing. There's a high voltage test and then a high current test. So the high voltage test is the attachment phase of a lightning event, where the blade is reaching out to the sky and it's connecting with this downward leader from the cloud, and they connect. And then there's a conduction phase, where the current flow starts. And that's what this IEC spec update is doing. It's measuring the current flow part, but not the high voltage part. And the high voltage part is where punctures occur. And that's where we don't have a lot of data. We have very little data actually from the field on that because it's difficult to do. And it would involve putting essentially electric field sensors in blades, maybe some other kinds of sensors in there, some magnetic field sensors, maybe some static field sensors in blades, which is possible, but you're not going to. It's very difficult to do once the blades are in service, right? So getting to the point that far out in a blade and sticking this device out there and then hooking a wire or a piece of fiber optic to it and running it down to some sort of SCADA system, data acquisition system, is really hard. Because blade punctures and blade damages start with the high voltage phase. And that section in the IEC spec isn't changing. And I think there's a disconnect between what's happening in the high voltage phase in the real world and what we're doing in the laboratory. They're different.
The high voltage phase is the attachment phase. That's where the damage is coming from. It's not actually coming from the discharge or the high current phase where they're wanting to measure. And so that leads me to one of the troubles that I have in reading this document. So the IEC standard or an IEC standard or any kind of standard or certification for any industry is a document or a set of rules, ideas, thoughts that you would build something to, right? They need to go to this phase because then, or to these, check these boxes because then they're good to go. What this annex is saying is we'd like to instrument them so we can learn from this and figure it out in the future. That's basically what these things are saying. And to me, that's not a standard. That's not something you would adhere to. It's just something that they're asking, like the OEMs, because I'm sure in these committees there is representation from OEMs. They're asking the rest of the world to instrument these turbines so that they can get data to fix their products in the future. I think that's backwards. I don't think that's the way this standard should work.
Right. You don't go out and acquire a bunch of data and then try to fix it in the next generation. That's the wrong way about it. Because you could get that information you need right now. If you really wanted it, you could do it now.
Yeah, it would be designed to work.
Yeah, we would have a lot less blade damage than we have right now. And it does seem like when there's blade damage, there's a lot of like shrugging of shoulders, like, yeah, that's going to happen. Why is that happening if the IEC standard is there and is doing a very thorough job? We don't let that happen in other industries like that, right? But for whatever reason, in the wind industry, we have now become acceptable to allow a lot of blade damage and then to shrug it off onto the operator owner to go pay for it. And I think, and then insurance companies get involved and it turns into this mess. And if on the research side, let's just talk about the research side, what this data would possibly give us. So if we go off and monitor a bunch of wind turbines and we start measuring the current parameters, what are we going to get? Well, we already have data on that. And so there's been a lot of data over a number of years where we've instrumented some towers and we're actually monitoring current flow. And what does it mean? What we're finding is, and Polytech has probably performed the most recent one, they instrumented about 1,100 turbines around the world and were measuring current parameters and then putting it into the probability of what lightning strikes are outside of the LPL1 requirement, right? So the LPL1 is like the highest level requirement for blades, and pretty much everybody tests to that at this point. So they looked at that on a lot of turbines and then did the probability. And basically, what they found was the current parameters fall or align with the existing IEC spec. That all the data they had previously for the previous 100 years in terms of lightning strike current flow matches what they see on turbines. That should not be a shocker. That's exactly what you should see. Because all the existing old lightning data from back in the 20s and 30s and the Empire State Building to towers in Switzerland and Italy and all over the place monitored lightning strikes to towers, tall things like wind turbines. So the currents there should match on a wind turbine versus what they measured years and years or years ago. So we have a lot of that data. And monitoring for more of it doesn't change. Is that going to change? You're going to see anything weird happening here on wind turbines in terms of current flow. That's not likely to happen at this point because we have so much data, so much history from all kinds of countries contributing to this lightning database. There is nothing we're going to learn that is new. The new part is what happens in the attachment phase, the high voltage phase. That's where the answers lies. And also, as we have been working on for a number of years now, the aerodynamics of the blade and how that impacts the attachment phase, because it does. It 100% does.
Within this standard, they're saying considerations and benefits for OEM, consideration and benefits for owner-operator, considerations and benefits for the insurance companies. However, having been involved in the insurance industry, fighting between OEMs and supporting asset owners, we also know that within the existing IEC spec, there is a 2% rule. And the 2% rule says, regardless of any metadata you have on this strike, 2% of strikes will cause damage. So even if you go back to that 2% metric, all of this monitoring means nothing except for research. Because you're not going to pin something on someone and say, oh, unless it's a 200 killiamp strike and you were rated and it was a 201, well, okay, then they can say force majeure. I get that. But that's such a minimal point within the spec or within reality of the strikes that happen. So I can understand that one, but the idea of instrumenting these turbines, we know how much it costs. To instrument these turbines with a full metadata suite, I mean, it's $3,000 to $5,000, $6,000 per turbine. Well, that just doesn't make sense in the real world of the idea of LCO, lowering the LCOE for the entire wind industry. You're all of a sudden, like if you're a wind farm in the United States and the IAC standard says you need to monitor or instrument all these. You got 100 turbines. You just got to spend $5 million. Like nobody's going to do that. I mean, or if you do, that's ridiculous. Like, come on. It just doesn't make much sense.
Because there's other ways to get that data in general. And the lightning location services, of which there are a couple of systems around the world, can provide you that information. If you want to know what the amplitude of the lightning strike was, just call them up and ask. Because as long as you know when the lightning strike occurred, they can give you the most likely lightning strike that hit the turbine. It can tell you what the peak amplitude is, what the specific energy is, what the rate of rise is. All those things with the monitoring system that would be installed on turbine, you can do that remotely fairly well at this point. So there's a trade-off there, right? You could use a lightning location service, or you could instrument a bunch of turbines. Now, which is cheaper? Well, I think the lightning location services are going to be the less expensive option there if you really want to know.
At the end of the day, Alan, we're doing the same thing here, right? You're realizing you took a strike and then going and looking at it. I mean, collecting all this metadata is good for engineers and stuff to have a job, pour through data, maybe figure something out. However, at the end of the day, we need these turbines to be spinning, and so you can instrument your turbine with a $100,000 instrumentation setup, but at the end of the day, it's going to tell you took a strike. Come take a peek to see if there's damage. What we need to do is be avoiding the damage in the first place.
You need to be avoiding damage, and there are ways to do that today. And the other thing you need to know is if you're taking if you actually taken a strike, which is a really simplistic piece of equipment actually, and then two, if there's any damage, because then there's something actionable for a technician or an engineer to go out and take a look at. Because if you take lightning strikes, and lightning strikes happen to wind turbines way more often than people think, right? There's a general consensus, which comes from the airplane world, that, well, wind turbines get struck roughly once a year per turbine. That's an airplane number. That's where that number comes from. It's not based on real lightning data on turbines. When you look at the real lightning data on turbines, you realize there's multiple lightning strikes happening to turbines, some of them, not all of them, depending on where they are, that it's much higher than the operators know because they haven't monitored it, right? They don't know how many lightning strikes they're taking, which is the first problem.
For example, Alan, you and I looked at some lightning data the other day, and in our analysis, we saw a turbine that statistically was hit 36 times last year. That was one turbine. So yeah, the data is it's a little bit different out there. But so let me shift gears here. If you want to protect your turbines, upgrade your LPS system. Because at the end of the day, you can instrument them, and find out when you took strikes. That's great. That doesn't save you any money. What you want to do is put something on like our strike tape lightning diverters that actually will work on that attachment phase, the high voltage phase, and get that lightning into the actual LPS system, so it's not puncturing the blades or blowing out trailing edges or those things. So there is other things we can do out there to upgrade LPS systems rather than just instrumenting turbines and waiting for strikes to happen and damage to happen to go fix them. Get in front of it, be proactive, and put something like strike tape on.
Yeah, there's no need to monitor for blades that are not taking damage. That's as simple as that. And we've been doing a lot of work on monitoring systems because a lot of the monitoring systems get passed through us from operators. They're asking questions about them, like, should we do this? There's a lot of variety of products out there you could choose from. And our response is, from an engineering side, because we work with a lot of operators and talk to technicians, is if you're going to choose to have a monitoring system, it needs to have actionable data. Something I'm going to do different that makes my outcome, my LCOE, lower. What is that? I think there's really one product at the moment that does that, and that's the ping system, the acoustic monitoring system, because they have a lightning sensor built in. So the lightning sensor tells if the tower has been struck, and then the acoustic sensor listens for any blade damage. So you can align lightning strike to blade damage. Once that alert pops up, then a technician knows what turbine to go look at, first off, and two, what they're looking for. Right? So you're not wasting a technician's time. What happens now with like the lightning location services that a lot of operators subscribe to at the moment is that system is not really accurate on where the lightning strikes occur. They know lightning strikes have been in the general area. And there's this general rule of thumb in the IEC spec, going back to the IEC spec, of the lightning to a turbine is going to be collected in an area of roughly 3 times the tip height. So a radius of 3 times the tip height is any lightning strike that kind of starts in that cylinder is going to go to the turbine. Well, when we actually look at that data, real data from the real world, that 3x number is wildly off. It's too small. It's probably 5, 6, 10, something like that, right? Based on the lightning location system, right? The lightning location services can't accurately locate lightning strikes, particularly upward lightning strikes, that accurately. And so you get a false sense of security from these lightning location services that you get. So if you were to look at the lightning strike map and go, okay, there's this lightning strike happens 600 meters from my turbine, I'm going to ignore it. The fact of the matter is you can't. You can't ignore it. And the only way to know that if your turbine has been struck is to put something on the turbine, because there's a lot of lightning strikes that happen near turbines that didn't hit the turbine. And there's a lot of lightning strikes that appear to be far away that 100% hit the turbine. So You're getting mixed data there right now.
Yeah, you're looking at basically you're going to pay for the efficacy of your data, right? So a lightning location service is by far the cheapest option. Um, and so with that cheapest option, you're doing something. You're being proactive. I mean, I like that idea. Like at least we're doing something. We're looking at data. We've got something to look at. How and those are going to be the cheapest ones. However, they might not be as accurate. You might have to open up the circles to 500-600 meters, 800 meters, 1,000 meters, depending on your location and the and the lightning detection network around you. Okay, so that's phase one. That would be the cheapest. Phase two, and this is why we like the product, is the ping monitor, because it is, of the monitors you can put on your turbine, it is the cheapest one. That's an on turbine monitor. And then you go to phase three, and that's when you start instrumenting. That's in the $3,000, $5,000, $8,000, $10,000 range per turbine, where you get massive amounts of fantastic data. At the end of the day, you just need to know what turbines to go look at to inspect.
You just need to know what turbine's been struck. You don't need to know what blade's been struck. That's the other thing that gets offered here is they can instrument each blade independently. There's on onshore turbines, there's nearly no need to do that. A pair of binoculars is going to tell you that. Just go down to the Walmart or DIY store and pick you up some binoculars. You can tell where a blade's been struck. It leaves a pathway there. You can see it. So from a technician standpoint, if the circle area of where a lightning strike occurs and that sort of the air radius is, if it's large, you're going to encompass 3, 4, 5 turbines in that. Right? So you know a lightning strike has occurred somewhere out there. Am I going to go look at 3, 4, 5 turbines every day a storm passes through in the United States? I'd be out there forever doing that, which is why they don't do it. So here are my recommendations for lightning monitoring systems. If you have a specific desire to be part of the research effort into lightning strikes to wind turbines, go ahead. Put a $5,000 to $10,000 lightning system onto your turbine and monitor what's going on. Look at the data. Great. Publish some papers. That would be wonderful. If you really want to have actionable information, 2 things should happen. You just need a lightning detector, and you need to have a lightning damage monitor that are inexpensive and simple. That's going to be your lowest cost option. And then, to prevent lightning damage to your blade, you need to upgrade the LPS system, because the mere fact that the IEC standard is going through this effort at the moment indicates that the IEC standard isn't doing an adequate enough job protecting blades from lightning damage. The reason they're going after this data is to, in theory, help themselves. I don't think that they will, but that's the goal here. So you could do this a lot less expensive yourself. Put a ping system in, monitor the blades with the ping system, put an upgraded LPS system on, and you're going to save yourself thousands and thousands, literally hundreds of thousands of dollars per year by doing that. And I think that's the easiest solution, and it's probably the most common sense one. And we're actually seeing results from the field from this now, where operators love this system and technicians love this system, more importantly, because they're not wasting time.
If I scroll back through this Annex L, considerations and benefits for the OEM, our solution doesn't necessarily help them because they're looking for that open checkbook to come and force majeure repair all the lightning damages. But it does help the owner operator, and it does help the insurance companies.
I think insurance companies are really going to step into the breach here over the next 12 to 24 months and say, we need to get this fixed because we're spending way too much time writing claims, reviewing claims for lightning damage that shouldn't exist in the first place because we all signed up to this IEC standard, which was supposed to stop this nonsense. And it didn't. So the feedback, I think, from the insurance companies is what's driving some of this stuff on the IEC committee. Right? The insurance companies are upset enough and the operators are upset enough that they're putting pressure back on the OEMs, like, stop this madness. Well, how do we do that? Well, we need to do more monitoring. You probably do, but not the things you're measuring right now.
Property damage in wind turbines. Property damage and business interruption costs are 2 separate things, but usually covered under the same policy. And a lot of times, business interruption can be 3 to 1, 4 to 1, 5 to 1 cost of the actual property damage. So while you may say, hey, well, we have a lightning strike and well, we've got to stop the turbine, it's only going to cost us $100,000 to fix, so we don't hit deductible. However, you've stopped the turbine. So once you hit 30 days of a stopped turbine, now you have a BI claim. And if this is a big turbine like what we're seeing being built now for megawatt, 5 megawatt turbine, your BI costs are going to go through the roof. So it makes sense to protect yourself by upgrading your LPS system and avoid that damage in the first place.
Joel, this has been a good discussion, and I know we hadn't planned on having this discussion a week ago because we just weren't that in tune with the IEC update, and then we got bombarded with requests to take a look at this thing and provide some comment on it. So I really appreciate you walking through this with me. I do think if people want to reach out to us, you can reach us at uptime@wglightning.com. You can send your comments and questions there. We'd be glad to answer them. But as this IEC amendment goes forward and a vote is coming up, I'm not a huge proponent. And just know that I understand where they're coming from. I think everybody's intentions are purely research intensive and are trying to do the right thing. I just don't think it's going to have an immediate impact on the industry. It may end up just adding more cost, unfortunately.
And that's from a lightning expert.